A ball is thrown upward with an initial velocity v0 from the surface of the earth. The motion of the ball is affected by a drag force equal to uh, okay, this is actually mkv squared, my bad, where m is mass of the body and v and v is its instantaneous velocity, and it's not y or k, is a constant. Time taken by the ball to rise to the zenith is. See, now I think we did a question like similarly a similar one based on finding the maximum height to which the ball is reaching, and therein we use the concept of integral calculus. So this is a very similar question, and we'll use a very similar way of deriving the answer. See, this I have to admit, it's the solution is going to be a bit lengthy because this is integration, and I'll make sure that every step is explained in detail. So if you're thinking that how long would it take to solve these kind of questions in the real exam, well, ideally it shouldn't be taking much time because you don't write much steps, right? You know what the integration is, you do submit the lower and apply the lower and the upper limit, and you have the answer in a very quick manner. However, here what we'll do is we'll try to make sure that every step is detailed and we understand the mathematical part of this problem very clearly. Having said that, let's move on to the solution. So this is the visualization here. So we have ground, which is at height is equal to 0. The object is thrown up with the velocity a from reference position a. It retards as it goes upwards. It reaches b. Its velocity becomes 0. And at that point, it is momentarily at rest. And when it is momentarily at, the corresponding height is in the maximum height, which is h max, which is what we will call as the zenith position, right? And then the object comes down. The question is to find out the time taken by the ball to rise from A to B. So let's try to understand the free body diagram of the ball. So we have the ball here. The ball is moving upwards for the motion along AB, right? For the motion along AB, the net direction of motion is upwards. How many forces are acting on it? There are two forces acting on it. One, which is the weight of it. Second, it is affected by a drag force, which means drag force is actually a resistive force, so it will be opposing the net direction of motion, right? So the net direction of motion is upwards. There are two forces acting against it, which is downwards. Now, if we use Newton's laws of motion, we have sigma Fy is equal to m into Ay, right? What is Ay? Is dv by dt. And why are we not here using v into dv by dy? Yeah, exactly. Very good. Now, those who are watching it online, please make sure that you try to answer this. Okay, so yeah, so that's it. So now what is sigma Fy? Sigma Fy is the sum of forces in the y direction. How many forces are there? There are two forces. What are their magnitudes? The magnitude is W equal to mg and Fd is equal to kmv square. Now, how do we choose their sign? The net direction of motion is upwards, which means the opposite, these forces are acting in the opposite direction, their sign will be minus. So we have minus mg minus kmv square is equal to m into dv by dt, right? So, okay, give me a minute. Now, I'll divide this complete equation by m. So what we get is minus mg by m minus kmv square by m is equal to m by m into dt by m by m by m by m is 1. So these terms can cancel off. I can take one negative common. So what I get is negative of g plus kv square is equal to dv by dt. Then I'll transpose this complete term g plus kv square to the right hand side. So we get dv by g plus kv square is equal to minus dt. Now see, a small manipulation here. In this step, in this complete denominator, I will divide it by the coefficient of v square. What is the coefficient of v square? The coefficient of v square is, let me just write it down here. Dividing by coefficient of v square, which is k. So now I have g by k plus kv square by k. So k by k is 1, and now we have g by k. Okay. Now since I am dividing it by k, I'll also have to multiply it by k, right? So we have 1 by k over here. Okay. Now, okay, so some students may have a doubt here. What I did is I just multiplied this complete denominator by k, and I also divided by k and also multiplied by k. Okay, that's what I've done. And this k, I have written it as 1 by k in this step. Okay, now instead of g by k, I have written root of g by k the whole square. What does it mean? Well, it basically means like this. So we have a by b can be written as root of a by b the whole square. Why? Because this root a the whole square, which is a, root b the whole square, which is b. Same logic. Okay, and then we have b square. Now if you see, this is of the form, this equation is of the form integral dx by x square plus a square, which is actually 1 by a tan inverse x by a. Now what is a here? A is root of g by k. Okay, so if we do the integration part, now what we get is, so we know this is we know the integral is 1 by a tan inverse x by a, where a is equal to root of g by k. So we have 1 by a into integral dv by root of g by 1 by k into the integral. Now what is the value of this integral? The value of this integral is varying from dv is the velocity is from u to final maximum velocity is 0. Why that limit? Because the ball is projected from a with some velocity u at the final point b, which is the h max, which is x max, the velocity, the body is momentarily at rest, and therefore the velocity there is equal to 0. So it's equal to 0. Now what is the integral? 1 by a. What is a? A is root of g by k. So 1 by root of g by k into tan inverse x by a. Instead of x we have dv. So v by a, which is root of g by k. Now we'll apply the upper limit and the lower limit. So we have 1 by k into upper limit minus lower limit. So this is upper limit. So we have 1 by root of g by k tan inverse, instead of v we'll have 0 minus 1 by tan inverse a, which is lower limit, which is u, right? Now what is tan inverse 0? Tan inverse 0 is 0. So 0 into 1 by root of g by k is 0. Now this remains 1 by root of g by k into tan inverse u by root of g by k itself. There is no variation in that. So if I take this further, this becomes minus t is equal to, why minus t? Because integral of dt is t. We have minus here. Upper limit minus lower limit is t minus 0, which is minus t. So now this becomes plus into minus. This becomes minus here, right? This and minus, these two minus, you will cancel. Minus by minus becomes plus. So these two becomes plus. 1 by k into 1 by root of g by k. See, now instead of root of g by k, I'll make the step more clear here. Can I write this as root g by root k, right? So 1 by root g by root k will become actually 1 by root g into root k, right? Now what is root k? Root k is k to the power 1 by 2. So I can write as k to the power 1 by 2 by root g. So this is k to the power 1 by 2 by root g. Okay, into u 1 by root g by root k is the same logic. K will go to the numerator, so I'm going to root k into u. Okay, so I think that much portion is clear. Now if we go to the next step, what is 1 by k? Okay, so I think I should clarify this thing. So now we have k here and root k by 2 into k raised to 1 by 2 denominator. So this is k by 2 by k, which is equal to k to the power 1 by 2, this is 1 minus 1, which is k to the power minus 1 by 2, which is actually 1 by k to the power 1 by 2, which is actually 1 by root of k. And that's how we get 1 by root k in the denominator, and the rest of the value remains unchanged. So this is the expression for the time of, well, not the time of flight, but the time of ascent, to be moved, time of ascent. Okay.